Welcome to part 2 of solving multi-step equations. Let's begin. The first step tells us to apply the distributive property. We can do that over here by multiplying 2 times 7x, giving us 14x, and 2 times negative 25, giving us negative 50. I will then simply bring down all of the parts of the equation that I did not change. I'm also going to draw a vertical line through the equal sign so that I can keep the two sides of the equation straight. So then we're asked to combine like terms. Remember, this only applies to terms that are already on the same side of the equation. If we look on the left side, there's only one x term, and on the right side, again, there's only one x term. Since these are on opposite sides of the equation, they are not considered like terms that can simply be combined. Similarly, I have a negative 8 on the left side and a negative 50 on the right side. They are on opposite sides of the equation right now, so I cannot simply combine them. So I can't do anything with step 2. The next thing I'm asked to do is to move all variables to one side of the equation. So notice I've put this hint down here for you, and this is a preference, not a rule, but what I try to do, if I can, and it's not always possible, I try to move my variables so that I end up with a positive coefficient for x, or whatever the variable is. And I just do this because of human error. Sometimes it's easy to drop signs or make mistakes when you're working with negative signs. If you give yourself a positive coefficient, then you're just less likely to make mistakes. So in other words, I could, if I wanted to, subtract 14x from both sides. But as you can see, that would give me a negative 6x, which is a negative coefficient for x. So that's absolutely valid if you want to work through this problem that way and prove to yourself that you'll get exactly the same answer as what I get, then please feel free to do that and take the time to do that. So, oops, I'm sorry guys, what am I doing? There we go. Okay, so what I'm going to do is I am going to, instead of subtracting 14x from both sides, I'm going to subtract 8x from both sides. And notice that when I do this, 14 minus 8 is 6x. So now I have this positive coefficient. And again, this is just sort of like a piece of advice to save you some trouble in the long run. If you can't do this, if you have to have a negative coefficient, or if you don't remember to do this, you can still absolutely 100% get the right answer. Okay? So now we are asked to move all the constants to the other side of the equation. Well, what do we mean by the other side? Well, we mean the side where there is no variable. So that's this side over here with the negative 8. So again, another hint here is to move terms away from the variable, not towards the variable. So in other words, if I added 8 to both sides, it's not exactly wrong, it's just going to take me an extra step to isolate my variable. So a faster, more efficient way to isolate my variable would be to add 50 to both sides of my equation. So negative 8 plus 50 is positive 42. So I get 42 equals 6x, and then I can do this step here, isolate my variable. I do that by dividing both sides by 6, and I get x is equal to 7. Again, I can always go back and put 7 in place of x, wherever I see x, in order to check my work. Okay, so I have 56 minus 8 is equal to 2 times the quantity, 49 minus 25. 56 minus 8 is 48, and 2 times 24 is also 48, so we end up with 48 is equal to 48, so that checks out. Let's do another example. Number 5. So again, we start by applying the distributive property, if there's anywhere to do that, and there is here. So I have negative 4 times 1 is negative 4, negative 4 times x is negative 4x. Then again, we just, of course, bring down the rest of the equation. Once again, I'm going to draw a vertical line here, so I keep the two sides of my equation straight. Next, we're asked to combine like terms. Unlike the previous problem, hopefully you can see there are like terms. There's a negative 4x and a negative 3x on the left side. So since they happen to be on the same side of the equation, we can go ahead and combine them. So we're going to have negative 4 minus 7x equals, and then same thing here, negative 7 plus 10, those are also like terms. We can go ahead and combine them. That gives us positive 3. So now I need to move all the variables to one side of the equation. Well, there's only one variable term, in other words, one term that contains a variable, and that's negative 7x. So I don't really need to do this step. Now I want to move all the constants, in other words, the terms that don't contain a variable, to the other side of the equation. And again, let's remember this hint, right? We want to move terms away from the variable, not towards the variable. So in other words, you might be tempted to subtract 3 from both sides, but that's moving the 3 closer to the variable, which is not what we want to do. Instead, we want to add 4 to both sides because that moves the 4 farther away from the variable. So that gives me negative 7x equals positive 7. And then we can isolate our variable here by dividing both sides by negative 7. And that looks weird. We get x equals negative 1. Okay? And as always, we can go through and check our work. So I have negative 4 parentheses 1 plus negative 1 minus 3 times negative 1 equals negative 7 plus 10. So negative 1 plus 1 is 0. So I have negative 4 times 0. Negative 3 times negative 1 is positive 3. Negative 7 plus 10 is positive 3. So I literally have 0 plus 3 equals 3, or 3 equals 3. So that checks out. Let's do another problem. So again, we're going to start by applying the distributive property. Here you can see there are no parentheses, so that is not a necessary step. So then we try to find out if we have any like terms. You can see here we have a negative 9 and a positive 2. We can combine them without moving anything to the other side of the equation. So negative 9 plus 2 is negative 7. Likewise, on the other side of the equation, I have a positive 9x and a negative 5x. When I combine those, that gives me positive 4x. Now we want to move all the variables to one side of the equation. So in this problem, we have a positive 3x on one side and a positive 4x on the other side. So I could, if I wanted to, I could absolutely subtract 4x from both sides. However, please note that doing that would give me a negative x or a negative 1x. This is not wrong. That's absolutely a valid thing to do algebraically. However, my preference is to try to get a positive coefficient for x because I'm human and I know I make mistakes, and if I can avoid negative signs, if possible, that's going to reduce the probability of me making a mistake. So again, this is a preference, not a rule. I'm going to subtract 3x from both sides, and then hopefully you can see that gives me a positive 1x or a positive x. Again, not right or wrong, just a preference. Okay, now we want to move all constants to the other side of the equation. Other side meaning where the variable is not. So you might be tempted to add 7 to both sides because you're like, oh, that would give me a positive number. However, if you do that, that's going to actually make things harder for you. It's going to give you make an extra step in solving this equation. We want to move our numbers away from our variable. So the number that's on the same side as the variable is 13. So we actually want to subtract 13 from both sides, even though it does give you a negative sign, and that's okay. Okay, so now I've isolated my variable. I have negative 20 is equal to 1x, or 1x is the same as x, so I could just say negative 20 is equal to x. And as always, we can go back and we can check our work. So I have negative 9 plus 2 plus 3, oops, not x. I'm going to put negative 20 in here. Clean this up, equals 13 plus 9 times negative 20 minus 5 times negative 20. So I have negative 7 minus 60 equals 13 minus 180 plus 100, and you get negative 67 is equal to negative 67. So that checks out. Let's do one more example. Alright, here's another example. So we have 3 parentheses x minus 2, close parentheses, minus 5 equals 7x plus 3. Again, we're going to start by applying the distributive property. 3 times x is 3x. 3 times negative 2 is negative 6. Bring everything else down. And I moved this over just so I would have more room. So I'll start drawing my vertical line from here. I just wanted to have more space. So my next step is to combine like terms. So hopefully you can see that negative 6 and negative 5 can be combined. That gives me negative 11. And then we want to move all the variables to one side of our equation. So we have a 3x over here and a 7x on the other side. So what I can do is I can subtract 3x from both sides. I just want to take a minute and point out, okay, if your first instinct was to subtract 7x from both sides, okay, you could absolutely do that. That is a valid thing. But notice it would give you a negative 4x. Again, nothing wrong with that. I'm just exercising my preference for positive coefficients whenever possible. Again, not right or wrong, just a preference that I have. Okay, so we get negative 11 is equal to positive 4x plus 3. Okay, now this is not a preference, this is really a mandate. We need to move terms away from the variable, not towards the variable. Okay, so we're trying to move all constants to the other side of the equation. Again, the other side of the equation means where the variable is not. So the variable is not on the left side, so I need to move this 3 to that side. I need to move it away from the variable. Because remember, your goal is always, always, always to isolate the variable. Move everything away from it so that it's all by itself. So last step is, since I have a 4x or 4 times x, I can divide both sides by 4. So we have negative 14 over 4 is equal to x. However, unfortunately, if you left your answer this way, you would not get full credit. Well, why is that? Well, the simple answer is because you always have to reduce fractions. This isn't necessarily something that instructors will even mention or tell you. It might even be assumed that you know this, but it is true. Okay, so we always have to reduce our fractions. So if I have negative 14 over 4, I can actually divide top and bottom by 2, and it reduces to negative 7/2. Now you might be thinking, hey, look, I could put this in my calculator and that would give me negative 3.5. And that's absolutely true. However, we stay away from decimals for the simple reason that sometimes, for example, if I had the fraction 2/3, I can't represent that exactly as a decimal. If you type 2 divided by 3 in your calculator, you get something that looks like this, and eventually there's a 7 at the end of it, okay? And because this is not an exact representation of our answer, we tend to prefer, okay, and sometimes your instructor might actually require your answer to be in a fraction, not a decimal. Another thing you might be thinking is, hey, that's a mixed, it's an improper fraction. You might be tempted to say, well, that's actually, 2 goes into 7 3 times, and there's 1 left over, so that's negative 3.5. These are called mixed numbers. But think about if you had to put negative 3.5 back into that equation, that's going to make, evaluating and checking your answer kind of miserable. So we also don't do mixed numbers. So we don't do decimals, we don't do mixed numbers. We just leave our answer as an improper fraction that's reduced as much as possible. So just for the sake of argument, let me erase this so I have some room here. And let's actually substitute negative 7/2 into the original equation and go through that and check our work, okay? So we have 3 parentheses, negative 7/2 minus 2 minus 5 equals 7 times negative 7/2 plus 3. Oh goodness, this is a doozy. Okay, so what we need to do is we need to make this negative 4/2, and this becomes negative 49/2, and this becomes 6/2. So this becomes negative 11/2, this becomes 10/2, this becomes 43. Okay, so 3 times negative 11 is negative 33. And I obviously very much ran out of room, but you can see that you do end up with negative 43/2 equals negative 43/2.